Let's name some simple organic compounds. If we have a monosubstituted benzene, we just name it with benzene as the parent name. So we got bromobenzene, nitrobenzene, propylbenzene. Real simple to do with a monosubstituted benzene. But if the benzene ring is not the major part of the molecule, for instance, if we have a alkyl group with 7 or more carbons, so that it's larger than the ring, that becomes the parent name of the compound. So here I have heptane. I have a benzene ring attached to carbon number 2, so we name that 2-phenylheptane. The phenyl group is a benzene ring that is attached by a single bond to something else. It's important for you to notice that the benzene ring carbon itself is not attached to anything more than just that one single attachment. So the phenyl group includes the benzene ring as well as one single bond coming out from one of its carbons. Also be very careful because a benzyl group is a 6-membered benzene ring plus a CH2. So something like a 6-membered ring with CH2Cl can be named benzyl chloride. Okay, it's all that CH2 right there that makes it into a benzyl group. So I know that's a little confusing with the nomenclature, but that's just sort of the way it is, and we kind of have to live with it. The phenyl group can be indicated in several ways. 5, 6, 7, 8. Let's just say I can actually just draw a normal benzene ring attached, or I could do pH. That's short for phenyl. Some places use a Greek phi, right, like that. Not nearly as commonly used anymore. pH is pretty common. So monosubstituted benzenes are pretty simple. If I have a di-substituted benzene, we can use ortho, meta, and para. So ortho is a 1-2 relationship on any benzene ring. Meta is a 1-3 relationship, and para is a 1-4 relationship where you have two groups on opposite corners of the benzene ring. So we can very commonly use ortho, meta, and para if we like. Right? Here is ortho dichlorobenzene. We'll come back to these ones. I'll come back to the one with the 2 methyl groups and the aldehyde to it later because they're common names that we'll talk about in a moment. But we can also number them. So just start at one of the carbons. I could call ortho-dichlorobenzene. I could also call it 1,2-dichlorobenzene. Okay, both are perfectly acceptable. We can talk about the ortho, meta, and para positions to describe regiochemistry of our reactions, which we'll do a lot of in chapter 16. So if I have something already attached at one site, if something else adds to it one carbon away, we can call that an ortho addition, or there's a meta addition or a para addition. For instance, adding bromine to toluene here with the methyl group adds para. Right? So this is a good reminder here. We use O or M or P for ortho, meta, para. Okay? The letters themselves are equally acceptable. When I have multiple substituents, more than 2, we do like we normally do, where we try to minimize the numbers, but you do it starting with the very first one. So start somewhere with 1 so that the second one gets the lowest number possible, and then number it so that the next one gets the lowest number possible, and so on. So there should end up being at least one right way of doing it. For instance, we didn't go 1, 2 here because then the bromine would be 5. Instead, we do 1, 2 for the methyl groups, and then the bromine is 4. So 4 bromo, alphabetize, 4 bromo, 1, 2 dimethyl benzene is acceptable. If I have, say, something like 4 methyl groups attached, with 3 of them next to each other and 1 away from it. We're going to number it always 1, 2, 3, 5, like that. So I started that way specifically because I wanted my second number to be as small as possible, and so on. So what do we got here? 1, 2, 3, 5 tetramethyl benzene. Now, since I said aromatic compounds have so much history to them, there are compounds that are known by their common names, so much more widely used than any kind of IUPAC names. So it is actually acceptable within IUPAC to call this subset of compounds by their common names. So benzene with a methyl group is toluene. Benzene with a hydroxide is phenol. Benzene ring with a NH2 with an amino group is aniline. C double bond O CH3 as acetophenone. We'll see quite a bit throughout this course that C double bond O CH3 is an acetyl group. So acetophenone is that compound. Any kind of phenone is something with a benzene ring and a C double bond O next to it, as we'll see. So here's benzaldehyde, C double bond OH attached to it. Here's benzoic acid, carboxylic acid, C double bond OOH. This is a picture of orthoxylene, but there's also metaxylene and paraxylene. Anytime we have 2 methyl groups, we call that a xylene. Here is styrene, okay? Benzene ring with a CC double bond attached to the ring. So benzene CH double bond CH2. So that is the monomer for polystyrene, where we do a radical polymerization with the CC double bond there. So with that in mind, let's go back to our names that we had up here. 2 methyl groups that are 1,3 to each other. This could be called metaxylene. Or if we use IUPAC 1,3 dimethyl benzene. We don't know the IUPAC method just yet to name compounds with an aldehyde like that, but I know a common name for a benzene ring with an aldehyde. That's benzaldehyde. So this is 4-chloro benzaldehyde. We could just as easily call that para-chloro benzaldehyde. We can use ortho, meta, or para anytime we have 2 substituents. So when we have a substituent on one of these compounds with a common name to them, we usually name it as a derivative of one of these, something aniline or something phenol or something toluene. So you are responsible for these common names. So make flashcards out of these ones. That way I can have something like this. I have 2 methyl groups, but an OH. So the OH group, we can call that 1. Methyl group is 1 away, so that's 2. Then the next one is 5. So let's call this first one 2,5-dimethyl phenol. All right. Here I have a single methyl group and 3 nitro groups around it at 2, 4, and 6. So this is 2, 4, 6 tri-nitro. Nitro is NO2. Toluene. The initials should look familiar to us. Tri-nitro-toluene. That is TNT. Powerful explosive. So anything with those nitro groups attached, like nitroglycerin, makes something explosive. So